Today, we'll explore the conditions under which a quadratic function is always negative or always non-positive. Let's consider the general form of a quadratic equation, ax squared plus bx plus c. First, let's look at when the quadratic is always strictly negative, meaning ax squared plus bx plus c is less than 0 for all real values of x. Think about the graph of a quadratic, which is a parabola. For the function's value, the y value, to always be negative, the entire parabola must lie below the x-axis. What does this tell us about the parabola? Firstly, it must open downwards. If it opened upwards, it would eventually go towards positive infinity. A parabola opens downwards when the coefficient of x squared, is negative. So our first condition is less than 0. Secondly, if the parabola opens downwards but still crosses or touches the x-axis, there will be x values where the function is 0 or positive. To ensure it's always negative, it must never touch or cross the x-axis. This means the quadratic equation, ax squared plus bx plus c equals 0 must have no real roots. The condition for no real roots is determined by the discriminant, b squared minus 4ac. For no real roots, the discriminant must be negative. So our second condition is b squared minus 4ac is less than 0. So to summarize, a quadratic ax squared plus bx plus c is always negative if and only if it is less than 0 and the discriminant b squared minus 4ac is less than 0. Let's look at an example. F of x equals negative x squared minus 4x minus 5. Here, I equals negative 1, which is less than 0, so the parabola opens downwards. Now let's calculate the discriminant. b squared minus 4ac equals negative 4 squared minus 4 times negative 1 times negative 5. This simplifies to 16 minus 20, which equals negative 4. Since the discriminant is less than 0, there are no real roots. Both conditions are met. A is less than 0 and the discriminant is less than 0, so this quadratic is always negative. Let's visualize its graph. Now, let's consider when a quadratic is always non-positive, meaning ax squared plus bx plus c is less than or equal to 0 for all real x. Again, for the function to be non-positive, 0 or negative, the parabola must not go above the x-axis. This still requires the parabola to open downwards, so the first condition remains the same. A must be less than 0. What about the roots? Since we allow the function to be equal to 0, the parabola is allowed to touch the x-axis at exactly one point, its vertex. It still cannot cross the x-axis, having two distinct roots, because then it would become positive somewhere. So we need either no real roots, discriminant less than 0, or exactly one real root, discriminant equal to 0. Combining these, the discriminant b squared minus 4ac must be less than or equal to 0. In summary, a quadratic ax squared plus bx plus c is always non-positive, less than or equal to 0, if and only if a is less than 0 and the discriminant b squared minus 4ac is less than or equal to 0. A simple example is f of x equals negative x squared. Here, a equals negative 1, which is less than 0. The coefficient b is 0, and the constant term c is also 0. The discriminant is b squared minus 4ac equals 0 squared minus 4 times negative 1 times 0, which equals 0. Since there is less than 0, and the discriminant is less than or equal to 0, it's exactly 0 here. The quadratic negative x squared is always non-positive. Its graph touches the x-axis at the origin. It's crucial to remember that if a is greater than 0, the parabola opens upwards. No matter how low its vertex is, an upward opening parabola will always eventually rise above the x-axis and go towards positive infinity. Therefore, a quadratic can never be always negative or always non-positive if a is positive. So, to quickly recap, for a quadratic to be always negative, it must open downwards is less than 0 and have no real roots. Discriminate is less than 0. For it to be always non-positive, it must open downwards is less than 0 and have no more than one real root. Discriminate is less than or equal to 0. Today, we'll explore when a quadratic expression is always positive or always greater than or equal to 0. Let's consider the general form of a quadratic, ax squared plus bx plus c. The graph of a quadratic is a parabola. The sign of the leading coefficient determines if the parabola opens upwards or downwards. If is positive, the parabola opens upwards, like a smile. If is negative, it opens downwards like a frown. First, let's consider when the quadratic is always strictly positive, meaning greater than 0 for all real values of x. For the parabola to be entirely above the x-axis, it must open upwards. So, the first condition is that a must be positive. Second, if the parabola opens upwards, it must never touch or cross the x-axis to remain always positive. This means the quadratic equation, ax squared plus bx plus c equals 0 must have no real roots. The number of real roots is determined by the discriminate, which is b squared minus 4ac. For no real roots, the discriminate must be negative. So, for a quadratic to be always positive, a must be greater than 0, and the discriminate must be less than 0. Let's look at an example x squared plus 4x plus 5. Here, equals 1, which is greater than 0. The parabola opens upwards. The discriminate is 4 squared minus 4 times 1 times 5, which equals 16 minus 20, or negative 4. Since it is positive, and the discriminate is negative, this quadratic is always positive. Now, let's consider when a quadratic is always non-negative, meaning greater than or equal to 0. Again, for the parabola to stay on or above the x-axis, it must open upwards. So, a must still be positive. This time, the parabola can either be entirely above the x-axis, no real roots, or it can touch the x-axis at exactly 1 point, one real root. This means the discriminate b squared minus 4ac can be negative, no roots, or 0, 1 root. So, the discriminate must be less than or equal to 0. So, for a quadratic to be always non-negative, a must be greater than 0, and the discriminate must be less than or equal to 0. A simple example is just x squared. Here, equals 1, which is positive. B and c are both 0. The discriminate is 0 squared minus 4 times 1 times 0, which equals 0. Since it is positive, and the discriminate is 0, which is less than or equal to 0, x squared is always non-negative. What if is negative? If the leading coefficient is less than 0, the parabola opens downwards. As x becomes very large, positive or negative, ax squared goes towards negative infinity. Such a parabola will always have negative values, so it can never be always positive or always non-negative. In summary, a quadratic is always positive if it opens upwards and is positive, and has no real roots. Discriminate is negative. It's always non-negative if it opens upwards, so is positive, and has at most one real root. Discriminate is less than or equal to 0.